Hey, we're going to be doing what's called the MoleLab. MoleLab. I like this little, what is this right here? Call Avogadro, 602-1023. That obviously is 6.02 times 10 to 23. Now, there's another virtual lab. You're not going to be able to touch anything, but honestly, well, the beginning part, there's not too much fancy stuff to touch. The second part, it would have been more fun, but you're not going to be able to do that. So there's a rubric. Make sure you read this, all right? It's worth 40 points. This is a big one. You got to do it. Needs a title page, a cover page there, and a conclusion. Now, you can't look at my numbers, but on this first section, we have 11 jars that are sealed up, and in each of the jars is exactly 1 mole of an element. And your job is to weigh those jars on the scale, put them on the scale, and write down the total mass of the jar plus the element. Now, each jar looks alike. They're very similar, but they're all a little bit different in size, and I use different amounts of tape and stuff. So we have to, I wrote down for you how much each jar weighs, the lid, the jar, the tape. That way, when you subtract out from the total mass, the mass of the container, you get the mass of just the element that's inside the container. Now, there are 11 different jars, and each jar contains 1 mole of an element on the periodic table. So once you write down the mass, and I gave it to you in the data slideshow, the mass of the jar, and then subtract the mass of the container, you get the mass of exactly 1 mole of an element. Now, it's a little more fun in school because you get to shake it and look at it and see it a little better, but you should be able to figure out exactly what element it is. For example, none of them contain mercury. None of them have a liquid, silvery colored metal. But the mass, if you put your finger in box number 80, 1 mole of mercury would weigh 201 grams. So if you weighed the jar with the element minus the jar, and the difference was exactly 201 grams, you'd be able to say, oh, that must be mercury because that's the only element. 1 mole weighs 201 grams. So you need to go through these, fill in the data table, and then do the subtractions, and then go to the periodic table because the mass of just the element is the molar mass. Then you can find the element with the closest molar mass to that, and you'll be able to tell me what the name and the symbol of those elements are. Now, in the next part, in the data slideshow, you can see this. There's 2 nails. One's little, but it's made of iron, and one's bigger, physically bigger, but it's made of aluminum. Now, aluminum has a lower density, and iron has a greater density. And even though they're noticeably different, there's a couple of pictures. There's a picture of the iron nail on the scale and a picture of the aluminum nail on the scale. There's a picture of both of them next to each other. The aluminum nail is noticeably bigger. The masses are almost the same, though. It's kind of weird. Like they look, you can see them. One looks 3 times bigger than the other. The aluminum nail is physically 3 times bigger. But the density is lower, and the masses are almost the same, but the densities are really off. So I wanted you to guess first which has more atoms. But to do this, you're going to have to actually do some math. You're going to have to take the grams of iron, convert that into moles using the molar mass, and then do another conversion to convert it into atoms. 1 mole is Avogadro's number. Then you're going to do the same for the aluminum, and you're going to see which one had more atoms. The answer is either iron or aluminum. You got to do the math, figure that out. The next part is actually a little more fun because we give you an Oreo cookie. I didn't give them to you. I ate some. My brother, my son, my daughter had a couple also. I put an Oreo cookie on the scale. I wrote down the total mass. And then I ate all the white stuff, all the sugar. Now the sugar, we're going to assume is completely sugar. It's mostly sugar. There's probably a little vanilla in it. But we're going to assume it's completely sugar. We ate that part, and I weighed it again without the sugar to figure out what is the mass of just a cookie part. And I subtracted to figure out how many grams of sugar are there. Now sugar that you eat like that, table sugar, it's got a chemical name of sucrose, and it's got a formula that's in the lab report, C12H22O11. Now that's a really big molecule. How many molecules of sugar are in an Oreo cookie? Well, take the grams using the molar mass, which you got to figure out. You can convert that many grams of sugar into moles, and then you convert from moles into molecules this time because sugar comes in molecules, not atoms. Next part, how many molecules are in one drop of water? So to do this, I did this, and you can see, I took a beaker and I zeroed it out on the scale, and I put 5 drops of water in, and I wrote down how much 5 drops was. I zeroed it out, put 5 more drops and zeroed it out. I kept doing this. 5 times I did it. And then I divided by 5, so I got the average of 5 drops. Then I divided by 5 again, and I got the average of 1 drop. So this is sort of a way, I measured a lot of water in sets of 5 drops, and then I divided and divided to figure out what the average mass of 1 drop of water was for me. Yeah, maybe you got bigger drops or littler drops. You know, everybody's going to have a slightly different answer, except this year because you're going to use my numbers. So whatever the mass of 1 drop of water was, you're going to convert the grams into moles, moles into molecules, and you're going to have an answer. Watch your significant figures. And then the last part, I showed you a sheet of aluminum foil. I cut it careful. 5.00 centimeters by 6.00 centimeters. It's a rectangle, not a square, but it's exactly, I gave you the numbers, 5.00 centimeters by 6.00 centimeters. And you're going to have to put it on the scale, and you're going to get the mass. And it's in the slideshow. Then you got to go through the problems. All right? And you got to go through the problems. And on the website, on abusif.com, there's an article, a post now. It's called How to Do the Mole Lab. And I kind of give you some hints on how to go through all of the questions. Then you got to write a conclusion. You got to put a cover page on it. And I got to have this before next Thursday. All right? Because it's going to be part of the first quarter grade. That's it. Mole Lab. Moles are fun. Mostly math. Sometimes, you know, it's fun to eat cookies. But putting nails on a scale or measuring drops of water is important. But really more importantly, it's the idea. Moles is central in chemistry. Moles means a mass, or moles means a number of particles. And soon we're going to see moles mean a volume of gas. All right, that's going to come in the next couple of days in the notes. All right, stay out of trouble. Short little Zoom. I love this job. Bye.